lawyer. I'm missing less than 20 people. That's not bad. I'm nearly to half capacity. I guess the long weekend. Here we go. Here comes some people. I guess some people did not survive the long weekend. I understand. Hopefully, I know in one of my classes there was somebody who was out kind of near the fires. So hopefully everybody's safe. I haven't heard from anybody else who's in that situation. I guess it's fire that's affecting us. Oh, I see. Well, there you go. That's a good point. There might be some people that can't connect because they don't have any electricity. So, damn. All right, Athena. Thankfully today, well, I don't know, out that way. Here it was a lot cooler today. I didn't close my windows today. That's the first time in a long time. I have no idea what it's like in Hummel. Okay. All right, so now I'm up to 20 people. Definitely over 50%. Anybody have any questions from anything? Homework stuff, general questions? There are some freaky problems. Yes.
I have one for 4.1.
Yes.
Number 12. I've done that one like 3 times and I keep getting the same answer.
And you know what's wrong? Is that, let's see, number 12?
Yeah, on 4.1. You said it was wrong.
I am such an asshole. You never know. Here we go. Oh, so what? All right. This is the one about if it's linear. Okay. So there is 0 work to do in this problem. How can I tell just by not doing a damn thing? How can I tell if something is not linear?
Because the y is squared.
Yeah, because there's a variable, doesn't matter which one, that is to a power that's other than 1. So why did I mark it wrong then if you said that?
I don't know.
All right, I have to look at that one specifically.
Okay. I said it wasn't linear. And I even solved for y just to prove it. And
oh, you probably solved for y incorrectly. So that's, did I cross through that part?
yeah.
There you go. You didn't have to, but you did. So then I'm going to have to tell you if it's wrong. So
okay, well then I'll
if you
just
didn't get a plus or minus square root business, then you did something not quite right.
Okay. Thank you.
Okay. You're welcome. And I just got a question in the chat. 4.2, number 36. Let me see here. Get down there. Come here. All right, 36. I can't even imagine. I mean, some of my, I'm bad enough with technology, but some of my colleagues, oh my God, I have no idea how their classes are going. So this one, find and interpret the Y-intercept. Let me make sure I remember what somebody was saying. Yes, 36. So if you do, so let's see, this might be one. Is this one where I didn't realize I should have made you do more of the problem? Is this like in a every third one situation? Probably, right? Oh, I'm sorry to hear that, Amber. So obviously, hopefully it's obvious. You either have to do number 35 to be able to answer number 36. Do you guys see that? Because how else are you going to find the Y-intercept when it doesn't go down? You know it's going to be, it looks like it's going to be negative, right? Right? Now, to be honest, there is a way to do this problem without finding the equation. If I didn't assign number 35. Yes? And if you're like, do you know what you assigned? I'm like, I have to look. It's a long time since I made that assignment. I can look right now. Where am I at? There it is. Yeah, it wasn't every third one situation. So, but the way I save my ass is you don't even have to find the equation. You can find the linear function and then finding the Y-intercept is easy. You guys semi with me? And you have enough information up here to do that. Yeah, exactly. Somebody said slope. If you find the slope, you actually should be able to do number 36 without the equation, but it might just be easier to do the equation. Is that all right? Person who asked me? Okay. And then number 44. Oh yeah, this is really good. Let's see. Okay. So this is another good one. They really like this kind of problem, which is fine with me. So let's see, use the median home values, and here's the years. So number 44 says, if we assume the linear trend existed before 1950, so you have to identify what the linear trend is, and continues after 2000, so it exists outside of these two. When will the two states' median house values be equal? I love this question. I would. I am an asshole. So the easiest way to do that, let me see. Does anyone have a suggestion on a good first step to do number 44?
So for 44, what I did is make two equations.
Yes.
All
right, stop right there. Oh. No, good. Okay, you're fine. So if you make the equations that govern the linear trend we're assuming is happening, then you can set each, and then you do what it says. When will the two house values be equal? Well, the equations represent house values. So this is what people don't really trust about math. You do exactly what I just said mathematically. You take each equation, set it equal to each other. Because that's what we just said we want to have happen. We want it to have happen, and math says, all right, make it happen. You got the shit. You got the stuff to work with. Is that all right? So that's the easiest way to do this. There are other ways to do this problem, but it's just a little bit, you got more to work with directly if you make the equations. So that sounds like a good idea. Is that all right? Person who asked the question? Okay, all right. And again, it's always okay if you don't get it after an explanation. It's my job to explain it in multiple different ways. So don't think I'm going to take it wrong. Can you believe that? Can you imagine if that was true? I already explained it. Well, I've had teachers like that. Anyway, anything else from anything? You can always private chat me like somebody's already been doing. Like I said, you could if you don't want to say out loud what you're having some trouble with.
I have a question for 4.1. 98, 99, and 108. It has to do with the calculator.
Oh, yeah.
How would we do that on the calculator?
All right, let me show you. Now that I've got my calculator app that I can access, let me first show you the problem. Load book. All right, so you said 98, 99, and what?
108.
108 is not a calculator problem.
Oh, I apologize. Apologize.
That's all right. It's a freaky ass problem, but it's not a calculator problem.
Is it okay if you go over that as well?
Of course. So let's look at 98. If you want to play along, and to be honest, I think there's a typo in this problem, but I'm okay with it because I think it's useful anyway. If you want to play along, go ahead and write that down. Y equals this. I'm going to open my calculator, and I want to have a domain of -10 to 10. And I want the, well, this is dumb. It just says it twice. It never says anything about the range. Okay, all right. This thing doesn't make any sense. So let me stop sharing. It's a free book, so it's allowed to not make sense sometimes. Those books that cost 180 bucks, when they don't make sense, it's like, what the shit? So let me open up my calculator. Come on, calculator. Every app takes forever. Okay, here we go. Let me share this. Now, of course, in the interim of all that, I have forgotten what the hell the freaking thing was. 0.02x. What was it again? 0.02x minus 0.01. So I'm going to go to y equals. Here I am in y equals. I'm going to put 0.02x minus 0.01. Okay. So if you hit that y equals, you can input any function you got. And then I want to set my X min and my X max to -10 to 10. And see how my Y stuff is weird? So does anyone remember what do I hit to make it go back to a 10, 10, 10, 10 window, a standard window?
Zoom 6.
Zoom 6. Yeah, makes sense. It's the one that says standard. Pop. Of course. I was doing some shit with my stats class. Give me a second. I just got to turn my stat plot off. Jeff, you got to actually do it, buddy. This whole part we're doing right now doesn't mean shit to us. That's just statistics. I'm very sorry. So if I hit Zoom 6, now this is fine. And I love it how people actually put in the homework, it looked like nothing. I'm like, I understand. But so what can I do to make this better? They don't say anything about what I could change to make this better. I mean, what's the problem here? Why can't I see more happening?
Your range is too large.
The range is too large. So if I go back to a window where I can control domain and range from my window, I could probably make Y max and Y min 1 and -1. Let's see what that does. It effectively just zooms in. So I hit graph now. That looks much better. I could even make it better. And just to show you a couple other little things. Is everybody cool with what just happened? I just changed the range on the calculator, right? It is a calculator, by the way. So if I go back to window, I got a couple more things I could do. Did you notice how I can maybe make this -0.5 and 0.5? No, Jeff. I could even zoom in a little bit more, right? And then what does this do? What the shit would this do? This Yiskel. What do you think is the right way to say that?
It's a Y scale.
Y scale. So let me make the Y scale 0.1. That makes more sense. That's the tick marks on the Y axis. So now if I go to graph, look at that. It's much better. Look at that shit. So this is 0.1, 0.2, 0.3, 0.4. Is everybody with me? Just a little more, a few more things. It's more of an aesthetic thing, but it just helps me tell what the points are on this thing. And of course, another button that's good is trace. It does exactly what you would think. Yeehaw, whoop-de-doo. All right, sorry. Okay, is that all right? I mean, that's gotta be all right. I basically just did the problem for you, so can't get more all right than that.
What do you want the graph to look like then?
So it's okay if you give me the graph as it looked before we changed the range, because
You
it
didn't
did.
like that answer either.
What did I do? What did I say?
You just keep marking X's through it.
All right,
Sorry.
hold on. I'd have to look at yours specifically to see if there was an issue. Oh shit, why did I do that? Barf. All right. Anyway, if you send me a message, I'll look at it specifically.
Okay, that's fine.
I might have been under the influence of something. So, any other? Oh, here we go. I got some more. All right, 4-1. Number 2. Do you see how excited I get when I get questions? All right. All right, 4-1, number 2. Here we go. Yeah, okay, this is a good, this one really tripped people up, and it's because, this one about Jessica, right? Person? Anonymous person out there in the world? Yes, this is the one. Jessica's walking home. After 2 minutes, she's 1.4 miles from her house. 12 minutes after leaving, she's 0.9 miles from her house. And it says, what is the rate in miles per hour? So a lot of you guys are figuring out the rate in miles per minute. That's not what it's asking for, right? So you got to go further. You just haven't gone far enough. Some of you guys are doing it in minutes per mile, which is different. You just have it upside down, right? We don't normally talk about minutes per mile. That just sounds weird. Is that all right? I don't know if one of those two things was the issue, because otherwise it's really just finding the slope. Can everybody identify the first point that they give us?
2 and 1.4.
Yeah, 2, 1.4. And the next one is 12 comma 0.9, and then you just got to find the slope, but you got to make sure that you end up in per hour. That's the key. And there's a couple different ways you can make it per hour. How many minutes is an hour?
60.
That's crazy. So 60, somehow that factors in. There's two different ways you can use that information to make it become per hour. So if that's the part you had trouble with, let me know. Otherwise, that's as much as I'm going to say. Okay, I'm not seeing anything more. Okay, that's good. Okay. Did I miss anybody else? No.
You didn't go over 108.
Oh, okay, thank you. Let me see. I guess was that in 4.2 or 4.1?
4-1.
4.1. Okay, I want to be here. Go away. I want to be here. Okay. Oh yeah, 108's awesome. So this is such a beautiful, and you're all like, of course you would like this problem, Jeff. But what I want you to start to realize is that the processes in math do not give the first shit what the actual details are. I am given 2 points and I'm asked to find the equation of a line, correct? That is easy, end of story. Did they give me a nice pair of points to work with? No. But does the process change? No, it does not change. This problem is a very just power through it. Just force it in there. You're like, let me get this in there so it can, you gotta, what do you have to do to find the equation? You first have to find, how do you find the equation of a line? 2 points.
The slope.
Slope. And then it's really up to you on if you are one of the people that solve for B, which you got to be careful for solving for B because there's actually a B in the problem itself too. So you might want to rename it MX plus C. Does that make sense? Why am I allowed to do that? Because who gives a shit if it's B or C? It's just what's called a dummy variable. It just holds a place. So you don't want to freak yourself out with too many B's dancing around. Is everybody with me so far? Or if you're one of the people that like y minus y1 equals m times x minus x1, you have a special place in my heart, number one. And number two, you just do the same thing you always do. It's not going to be as easy in a sense because you're not going to be able to combine things. They're going to be A's and B's running around. But the process doesn't matter. It doesn't change, is what I should say. I don't know. Let me see. Somebody else is asking about different problems. Is that all right? Who was asking me that? I already forgot who was asking me that.
This is me on
Is that
that.
all right? Oh, yeah. Is that
Yeah.
all right? Enough
Yeah.
to get you going? All right. So
Yeah,
just
got
have faith in the process. I'm given 2 points. It doesn't matter what they are. It doesn't matter what they are. The process will work. Yeah.
Okay.
Let's see. 30, 40. All right. I'm just going to go to it because I can't say where I'm going for some reason. Let me try. 33 and 4.2. There you go, Jeff. Oh, yeah. We did a problem sort of like this we talked about. It's just, again, you could either do what this one says to do. And I know I didn't assign 31, and that doesn't matter because to answer 33, it would be easier if I had an equation to work with, right? Would you go away a little long? All right. You with me, person? I call you person because I don't want to call you out.
No, you're good.
Oh, hey, all right. So now I can say it's Emily. Yeah, so if you could find the linear function and then just find the x-intercept, make the y 0. Or you could figure out the slope and actually just get you can figure out how long it would take you to get down. Now, of course, you notice the little heartbeat symbol there means you got a long-ass way to go. But it's probably easier just to make the equation of a line because then we know the process for that. Okay, I like it.
Okay, thank you.
You're welcome. There was another problem. Was it here? Yes. These problems right here. Did anybody do these problems? The town population problems. One thing I want you to realize is none of these problems say you have to find the equation of the line. Right? I don't think it said it anywhere. No. So you don't necessarily have to find the equations of these lines to answer these questions. Is finding the equation of a line a good way to do it? Yeah, it is. Is there an easier way to do at least like number 9? Yes, there is. But you can do it either way. It's fine because they don't ask you to find the equation line. So screw them. If there's a better way, do it. So just in case you're somebody thinking, I don't want to find the equation line. I know how to do it. I do it. Show me enough work and I'm cool with it. Okay. All right, I think we're good. Okay. So what I want to do is we are going to, oh, have I talked about this yet in general? Somebody was asking about chapter 4. Let me stop sharing. Go away. Chapter 4 quiz, because chapter 4 was not on the last quiz. So it's just going to be included on the next quiz. And the next quiz, which I looked up earlier, I believe it was September 14th. Is that right? That's not, yeah, next Monday is the next quiz. So on Monday will be chapter 4 and any of 5 that we get through by tomorrow. So it might not have as much of 5 on it as it originally was supposed to. Is everybody with me? Which is fine because it's got to make some room for 4 anyway. Okay. Okay. All righty. So now we're going to transition away from 4 entirely, unless anybody has another question from chapter 4. Or is there anything left over from chapter 3 for that matter? I mean, that's fine too. No. Okay. So we're going to get into parabolas. Let me see. And I always like, there's at least one person who's like, does he think that's how it's really said? I know, I gotta adjust, hold on. So let's review a few things we already know about parabolas. Okay, how do I need to adjust to? Like that, okay. So if I gave you a function like this, let me even make it a function. Why not? What can you identify for me? Wait a minute, I just got a question. I'm not really sure what you're asking, Joshua. I might have to go in there and adjust the chapter 4 due dates. Maybe that's the question. You can always, by the way, I did want to have a real quick discussion about due dates in general. In fact, I don't know if you guys noticed, I did change the due date for 4-2, I believe. It was this class. I can't remember now. But the due dates aren't like a do or die thing. Do you guys understand that? You can turn it in late. You only really get hurt if you turn a lot of stuff in late or if you turn something in very late. So if you turn in, you know, like chapter 4, 5 weeks from now, that will hurt you. I mean, it just will. But it's not going to like, you know, it's still going to be worth a decent amount because I want you to do it because the final is going to be cumulative, right? So on one hand, I want you to do everything before the final. So I'm going to make it worth something. So you'll be motivated to do it. So don't drive yourself insane at 11:53 p.m. trying to turn that. So just go to bed. Do it the next morning if you have time, and then turn it in. It's not going to kill you. Is that all right? You guys are with me? So the due dates are semi-arbitrary on my end. I do try to make them so that you get all the stuff done that's going to be on a quiz soon, but there is some wiggle room in between. Is everybody with me on that? So if you think that I should adjust the chapter 4 homework due dates more, you can email me and ask me, and then I can see if I feel the same way, and then I'll change it if I agree. Oh yeah. Well, I think I changed 4-2 to today, right? I'm pretty sure I did. You just checked, so maybe I'm lying. I'm such a liar. I'm sorry. I thought for sure I changed. Email me right now and say, look at the chapter 4 due dates, and I'll take a look, okay?
4.1 and 4.2 are due today.
Oh, I changed both of them. Okay,
Yeah.
good. All right, back to
thank
this. So somebody just emailed me. You can always ask me to look at them, and I can just tell you, I disagree, too bad for you, or I can say, okay, I changed it, right? So if you ask, something might happen. What can somebody tell me about this graphically? Can somebody give me one piece of information about this?
The vertex or like point is -1, -2.
I love it. That's a very good technical piece of information. Does everybody agree with that? Could be wrong. I just wrote it down because she said so.
Yeah, that's right.
Okay. Yeah, Ahmed, you good?
Yeah.
Okay. Because it's right. It's correct. And we all know even better now because of all the talk we had about transformations. So that's one reason why we study transformations beyond just being able to graph stuff easier. It's so I can analyze stuff like this very quickly. What else can somebody tell me about this?
Isn't it moved over to the left?
Yeah, so this basically captures it, doesn't it? This captures both shifts. It's moved to the left one, down two. I like it. But you're right, that happens to the whole graph. But the vertex pretty much sums it up. What else can you tell?
The base function is x squared.
Okay, I like it. So the base function is x squared. So we know the shape is going to be a U. And of course, I just gave something else away there, but it opens
Upward.
up because it's positive, right? Yes. Okay. I like it. And then, so let me see. There's one more thing you can tell me that you have to do a little bit of work for.
There's going to be 2x values.
Yeah, 2 X-Intercepts.
Yeah, that one you know without any work because you know it's shifted down and over. So you know it's going to open from below, so it's going to hit it twice. I like it. I'm not saying it's going to look like that exactly. We'll see. But I want something more tangible. So if I plot the vertex, -1, -2. What is really, really nice about this function in terms of, oh, screw it. I'm just going to tell you. It's symmetric. This is not symmetric around the y-axis. It's symmetric about what? What will this parabola be symmetric around now?
-1.
Be a little more open. I know exactly what you mean. You are correct, but be more precise.
Is it x equals -1?
Yes, it's going to be symmetric around the line x equal -1 because everything's shifted back 1. It used to be symmetric around the y-axis. Now it's going to be symmetric around this. And I love this thing's name. The line I just drew. Does anyone know its name?
Line of symmetry.
Yes. In fact, it's even more interesting for those of us, any older people out there that know the axis of evil days. Remember that? The axis of evil. No, the axis of symmetry. Back in the days of George Bush. That's a terrible George Bush impression. Let me try again. I can't do it. Screw it. I'm gonna stop. All right. Woohoo! So now here's the neat thing about this. This is a mirror. So any other point that I know, I automatically know its reflection point. This is a mirror. So if I just knew the Y-intercept, how do I figure out the Y-intercept? Of anything. How do I?
Make x 0.
Yeah, so for anything in the universe, how do I figure out the Y-intercept? You make x 0. Can you guys see that color? Yes. What color is that? Ooh, whatever color it is, it's good for getting high. So when I do this, I get
-1.
-1, kick ass. So I know, let me do my graph in a different color. There we go. So I know there's the y-intercept is right there, right? It's at 0, -1. So where is there another point without doing any more work?
-2, -1.
Yes, -2, -1. It's got to be its reflection has to be there also. So then I can just give it a little bit of a, well. Now let me ask you this. Is everybody cool with what we've done so far? This isn't much more than we've done. We didn't talk about this before, but I'm hoping it makes sense. The mirror is going to move, and then I can use that. I can use the fact that it's a mirror to help save some work. Can you guys please figure out exactly what the X-intercepts are? I can tell you approximations, but I want to know exactly what they are. Let me see if somebody gets my meaning. Don't say anything out loud. Don't type anything in the chat. Just try to figure out what the X-intercepts are.
Is it -1 plus and minus square root of 2?
Yeah, let's see. So the easiest way to figure out the X-intercepts is to set this thing equal to 0. Make y 0. Then you just have to add 2, take the square root, and then subtract 1. So I get plus or minus or add 2 minus 1, or you can write that as -1 plus or minus rad 2 if you want to write it like that. It's kind of a little bit better to put that plus or minus in the middle. So let's see if this makes sense. Rad 2 is about 1.4. So -1 minus 1.4 is -2.4, which is about where that is, right? Even on my shitty graph. And then -1 plus rad 2 is -1 plus 1.4 is about 0.4, which is about where that is, if you give me a little leeway. It's almost where that is. Are you guys, is that all right?
Yeah.
Okay, I like it. Okay, so if you get a problem where they, now, do you see how useful this form is? That form is useful. It's sort of like, if they give me a line in the form mx plus b, I know every damn thing about that line. If they give me a parabola in the form this, I know the vertex, which is enough to get me going. So what if they don't give it to me in this form? Ooh, all right. So, does anybody still need stuff from here? Can I erase this? I don't know why I'm swimming. Okay. So what if they give it to you in this form? What you got, Jeff? I don't know, Jeff. Let's just start off nice. See how that feels. I don't like it. Yeah, it's all right, Jeff. You'll be all right. Now, one nice thing about this form is what can you see without doing much work at all? What can you identify immediately? Besides, it's a parabola that opens up. I know that already. Sorry, go ahead. Anybody? No? What's the y-intercept?
Isn't it 0, 24?
Yeah. That's the kick-ass thing about this. Since x goes to 0, leaves only that, that's going to be the y-intercept. 0 that, right? So that is one advantage this form has. So the y-intercept is 0, 24. Can you tell what the vertex is easily? Some of you guys might know the shortcut, but let me see if you guys, we're going to develop the short. Sorry?
No, it's like the formula for the vertex is like -b over 2a.
Yeah, let's see where the hell that comes from. Do you know where the hell that comes from?
The quadratic formula?
Yeah, yes, I love it. All right, all right. I'm not going to keep going because I was going to ask you, do you know why we use that part of it for the shortcut? Not just because we liked it. There's a reason. All right, so we're working in that direction. Okay. So, what can I do with this, though? Could I find the X-intercepts easily?
If you were to factor out, yes.
Yeah, of course. So what do you get when you factor this bad boy?
X minus 3 is X minus 8.
The X-intercepts will be,
X equals 3, X equals 8.
and let me make a big deal out of this. Nothing against you, Brian, trust me. X and Y-intercepts are points. When you answer a question about intercepts, you better give me points. Okay.
Yeah, my bad.
No, Brian, you're good. Don't worry. Everybody did that in the homework, or just about everybody, where they asked for intercepts, and I try to make a big deal out of that when I was grading. I think. We'll see. So they have to be points. Now, let me plot what we know so far. I've got enough to kind of get going a little bit, but I still want to know what the vertex is for sure. So why don't we go by, let's go by 4s, maybe. Or what about, well, let's go by 8s, Jeff. Yeah. So I got, so this would be 8, 16, 24. I like it. And then here I can go by 2s, maybe. Yeah, 2, 4, 6, 8. Okay. So then I've got 0, 24. I've got 3, 0. And I've got 8, 0. That's still not enough, really, because the most important point is still unknown, right? Where is that last point that I need? Where will it be? What is that last point I need, of course? What's the most important point on a parabola?
The vertex.
Vertex. Where will it be?
In the middle between 3 and 8.
Yeah, it's going to have to be in the middle of the two X-intercepts because it's symmetric, boogie woogie, right? So it's got to be in the middle of those two. So what will it be exactly for this?
5.5.
Yes, 5.5. You just got to average 3 and 8, right? Is everybody with me? So the vertex is going to be, here's 5, here's 5.5. It's going to be on this line somewhere. So I know that the vertex is 5.5 comma something. Let me stop for a minute. Is everybody cool with where that 5.5 came from? It's because of symmetry. So how do I figure out where exactly it is on this little dotted line?
Plug it in.
Plug that in, that shit. That's right. So take a minute to do that for me. Plug 5.5 in. Let's see what I get. Is it negative 6.25? Does that make sense? Yeah, it does. I don't
Good
know.
job.
Is that right?
Yeah, that's right.
Thank you. You don't have to sound like surprised. sorry. Maybe you should. So it's about 6.25, which is exactly right there. So this is going to be 6. Ooh, get out of there. Let's complete the vertex over here. 6.25 negative. So all we did was we plugged 5.5 in here or there. It doesn't matter. They're the same thing. All right. So what I want to, and then of course we're done. We can even get one more point. See how this would be a little bit gross. I don't really need to, but that's 5.5 to get to 24 up. So if I go 5.5 this way, I can go 24 up again and get the reflection point, but I really don't need it. So I say, screw it. Okay, but I could always get the reflection point if I wanted to. All right, so what I want to focus on then is, what's the shortcut, especially when I'm not able to factor this damn thing? Now, if I'm not able to factor something, how do I find its X-intercepts?
Quadratic formula.
Quadratic formula. That's crazy ass shit. I think I'm gonna eventually show you. There's a mathematician. Okay, the neighbors are out. There's a mathematician that came up with a simplified way of doing this without the quadratic formula. It's simplified in a certain way. So I got to figure out where the best place to put it in this course would be. So what is the quadratic formula?
Negative b plus or minus the square root of something, something, something. 4ac.
That's right.
4 minus b
B
minus
squared.
4ac.
Minus 4ac all over 2a.
Where does that come from, by the way?
Pythagorean's theorem.
No. Thank you for playing. It was good. It was a good guess. I can't take you away from that. It came from, who knows, a fever dream of one of those mathematicians. I might prove it to you in a minute. We'll see. But notice this. Let me rewrite this a little bit. I'm going to rewrite the exact same thing here just again because I'm a little crazy. I just rewrote the same thing again, right? Do you see how this says negative b over 2a, give or take the same amount? So whatever the x-intercepts are for anything, what is right in the middle of them is this. Because it starts here and it goes up that much and it goes down that much. So of course what's going to be right in the middle? Frickin' negative b over 2a. That's what. Yes, yes, yes. That's where the shortcut comes from. So let's see. So what am I trying to say? I don't remember. If I go back up to this and I apply the shortcut, what is b?
Negative 11.
Yes. And what's a?
24.
No. Thankfully. That's c, right?
1.
C. It's going to be 1. So I get 11 halves, which is 5.5, which is what we got for the x piece. So that is a shortcut to doing the weird shit we did that we couldn't even do if I wasn't able to factor this. Maybe? Okay, okay. Let me see. I'm trying to figure out how much I want to try to cram in today. So here's something amazing. If I have how many problems, how many real life problems are parabolic in nature? And that's such a weird question. You guys should have some feel for how many real life problems involve parabolas.
A lot of physics?
Yes, a lot of physics, which is basically physics is life. So a lot of life. So what's funny is I'm catching up on my shirts. I referenced this shirt the other day. I should have worn my basketball shirt tonight, and I didn't even think about it until just now. But one situation that would be parabolic in nature is if I throw something and I'm in a vacuum chamber somehow, and I'm still alive because I got to neglect air friction. So if I throw something up, it comes back down. I now have, if I knew the equation of this thing's trajectory, I have a shortcut to figure out where the maximum height occurs, right? If this axis is time, 0 to whatever, who cares? Put a W for whatever. I can figure out where the max height occurs because it's just the freaking vertex. I have a shortcut. This will be x equal negative b over 2a. That'll be the x piece. So how do I get the y piece? I just plug it into the equation. Let's try a problem out. Let's try a problem out. So what if I had, oh, let's see. Okay, we can do it, Jeff. You can do it. Dun, 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 dun. It's going to be easy. It's going to be simple. There you go, buddy. There you go. Sure. Okay. I like it. What is the x piece of the vertex? What's the shortcut?
In the middle.
Yeah. That's the idea that led to the shortcut. Now, what is the shortcut?
Negative b over 2a.
Negative b over 2a.
Yes. So if this is the problem, if they say this is the trajectory of something that somebody threw, what is the maximum height it attains, and when does it attain it? So x is time, f of x is height in meters. Why not? Let me give this real life shit happening. X is time in seconds. Height in meters. I love it. So we're using like real units that the rest of the world uses. Yeah. So of course b is 12. So negative 12 over twice a is negative 2. So then I get
3.
3. What does that mean?
It takes 3 seconds to
Yes.
reach its max height.
I throw it. It takes 3 seconds to get to the maximum height. Or it could be a rocket that I shot off or whatever. And then how do I find, of course, this piece?
Plug 3 back in.
Plug 3 back in. So I get 36 plus 3 is 39 minus twice 9 minus 18. I've already forgot what I said. I think it's 21. Is that right? Can you follow what you're saying, Jeff? If you can't, what about them? I don't know. Is that right? 39 minus 18, yes. You guys cool with that? So this is going to be 21 there for this specific problem. What is this going to be, of course? Well, not of course, I'm sorry. This is a little bit different. This isn't really the picture of this. Can you guys see why? Let me stop labeling it like it is. Why is this not the picture of this?
Because your
What's
Y-intercept's at 3.
Y-intercept, I love it. So this is if I had something in my hand 3 feet off the ground. Where's my hand? There it is. Get up there. Hello, internet. So if I had something in my hand 3 feet off the ground and I threw it up in the air, so it would actually start 3 feet above the ground and go up from there, right? Okay, maybe. That came out pretty nice. So this kicks so much ass. Anybody have one more situation in real life where there might be parabolic or, quadratic shapes involved?
Bullet trajectories.
Trajectories in general. So we got that covered. Good try, though. I like that. You mean like, what about a brick trajectory? What about a can of soup trajectory, Jeff? I don't know if anybody gets that reference. Got to watch out for that weaponized candles. All right. Sorry. It's just, he writes his own material. It's like nobody needs to work anymore. So one more place where this definitely happens. There's a ton of places. You will find out how many places. There's a shit ton. But I was hoping somebody would come up with is like a profit function. So it's a very simple profit function. So I know people in business wish the profit function looked like this, because then you just keep on moving up this way and you can make it go. But no, profit functions look more like this, where there's a definite goal you want to. Now, later you learn there's more shit going on, and profit functions could look like this, and where you have a really good goal, or if you can't get past here, then this is your best goal. Anyway, that's a little further than I wanted to go. That's where you would take this in calculus. So we got to rein this shit in, because we can only deal with this shit, because we know how to find that max height. So that's just one other situation. There are an infinite number of other situations where a parabolic shape could show up. Okay, what else did I want to show you? Oh yeah. So I want to connect this. You can do it, Jeff. you could do it this form with the other form we had up here earlier. This might be a difficult one to start with, but let me see if you guys remember a little something called completing the square. Don't get too excited. I'm not going to draw this and then you got to go, is that right? Get out of there. No. Has anybody ever heard of completing the square? Let me start there. Does that sound familiar to anybody? If you have paid any attention to any of the handouts I put up there, I have put up a handout that goes over completing the square in the first little unit. But it's okay. I won't take it personal if you didn't. So what I want to do is this. I want to figure out if I have something like this, and I am allowed to add something here, what would I add there so it would factor like this? So for example, what is x plus 3 squared? What do you get when you FOIL it out? Do not tell me x squared plus 9. I will cry. What do you get when you FOIL that out?
X squared plus 6x plus 9.
Thank you. Don't lose that poor middle term. So that's what I'm talking about. You have control over what to put here so that it works like this. What's x plus, let's do this. What's x minus, what do you got, Jeff? 8 squared.
X squared minus 16x plus 64.
What are you noticing? What is this number? How does it relate to something here? How does it seem to relate to something here all the time?
It's double the second term.
Yeah, this number seems to be double this one, right?
Yeah.
If I call this C, then I know that 2C must be 8. Let me stop there. Is that cool? Twice 3 is 6. Of course it is. It's kind of dumb, isn't it? If you think about it. Well, of course, because I'm going to do 3 plus 3 and get 6. It's negative 8 and negative 8 and negative 6. Ooh, it's amazing, Jeff. But, right? So it's just realizing that and then using it. What's this connection? Those numbers, where do they come from?
C squared.
C squared. So you just have to solve this, right? So if you take, so here's the real, so realizing that's kind of like the motivation. What is the actual process I want to go through? I want to cut the middle dude in half, right? I want to cut the middle dude in half. That's what that would say. So the first step would be cut 8 in half. And of course you get
4s.
That's amazing. And then I want to take 4 and square it. Whatever I get from the first step, I square it, and you get
16.
So this is what must go here to make this factor like that. That is the process of completing the square. Hopefully that sounds familiar, maybe. All right. So how the shit? Let's do one more. Let's do one more. Has everybody got what they want from this business? And there's a much nicer, cleaner step-by-step on that handout that's up on Canvas, if you want that. It would be harder for it to be messier, but it's yeah. I'm going to take this away. So here's another one. Here's one I really, really like. Let's see. Of course, people hate me for this, but I don't care. The thing to realize is that this is the idea of a process again. The process don't give a shit. We start to give a shit until we realize I just got to follow the steps. I just got to power through. I know how this works. So what's the first step? What's always the first step?
So 2c equals -5.
Yeah, let's get past that. That was an intermediate step to get to the actual process. So the first step in the process is cut whatever this is in half. Because that's what would happen when you have 2c equals that, right? You guys, you with me?
Yep.
So the first step is cut the middle dude in half. And then what do I do with what I get?
Square.
Square. And I am so tired of decimals creeping in this shit. Fractions. Yo, damn it. For the most part. Sometimes decimals are all right. So what goes here and what goes there? This is where people get really confused. Where's this guy go?
25/4 is c, so it goes plus 25/4.
Yes. So the last thing you find goes on the first side. And of course, it kind of makes sense if you think about it, because that goes here now, because it is what you're going to square in the process to get this. So it makes sense where things go. Okay, maybe. Okay, so what the shit does this process have to do with this? And what do I have to do because something is not right up here? All right, so you're going to love this. This is going to be a bit of a big step, but we're going to do it. We're going to make it. I'm going to take this away. Go away. Can anyone tell me what is the big difference between this problem and the ones we did earlier? There is a single big difference.
A does not equal 1.
Yes. So the whole process of completing a square is hardwired on this being 1. So I have to rewrite this. Now here's the next place people freak out. I'm going to take a -2 out of these. Put the +3 way the shit over there. Get over there. Oh man, I got my neighbor's kids around and my windows are open. I gotta be a little careful. Damn. Mama, what is fuck shit damn me? Oh shit, damn. Fuck. All right. So we'll see if you guys get why I'm doing this in a bit. So then this is going to be x squared minus 6x. So now in here, this looks like one of the problems we just did, right? So let's focus on inside here. What are the steps?
Divide -6 by 2.
Good.
Square -3.
All right. So here's where things get really nifty. How many, this always gets me so sad. How many people have never seen the first Indiana Jones movie? Anybody? I've got a few people. Okay, I understand. Oh, it's old, Jeff. It's crap. No, it's back in the day when they knew how to make frickin' movies. Oh my God, I sound just like. Anyway, I'll stop. There's a scene in that movie that you've probably seen in memes or parodied or something, where he's got a golden little statue dude, but he's got to swap out the appropriate amount of sand, right? What does that got to do with this problem, Jeff? I don't know. I just like talking about it. Oh yeah. So what am I gonna do? Where does this 9 got to go?
Next to -6x.
Yes. Now, let's see if you get this. This is not right. But I might think I have to do this at the same time so that overall I didn't do anything to this side, but it's not the right thing to do. It's sort of like swapping that gold statue out with the sand. But that is not the right number to put there. If I add 9, I better subtract 9. But I did not just add 9. I did not. And this is where some of you guys think I'm off my meds again. What did I actually just do? Is this a 6 here? Is that really a 6 in this function? No, it's freaking 12, isn't it? Right? That's not a 1. This is a -2. I just took it. So what did I actually just do?
Added -18.
Yes. So I took 18 away. So at the same time, I better add 18. So did I just change this function at all? No.
No.
Did I make it look different? Yes. Because I'm not allowed to just come in and go, I don't like your function. Let me take this away. No, I'm not allowed to do that shit. So if I do something, I better do the opposite so that it stays the same. Okay, maybe.
Do we add 18 or subtract 18 there because of the -2?
Yeah, what we did was we subtracted 18. The minute I wrote this down, I subtracted 18. So how do I make it right? I add 18.
Gotcha.
So overall, I just did nothing. It's sort of like, here's a dumb thing. You ready? Sorry, just go with me. You can do it, Jeff. Make this, there we go. How would I do this? Wouldn't I have to multiply this by 3? And if I divide it by 3 at the same time, I didn't change the number at all. It's still the same problem. That's a really dumb example of exactly what we're doing. That's why you do this, because I just did the opposite of what I did. So overall, I did nothing. I just subtracted 18. I better add 18. So I did nothing. Right. Officer, I didn't do anything. So what do I end up with? How does this factor now? Remember, this one is what goes here, and this is how it factors.
X minus 3 squared.
Sorry. Yeah. And then what's outside?
Plus 21.
And what was the vertex we got earlier for this problem? This problem right here. What vertex did we get?
3.
Yeah. Sorry, go ahead.
Was it 3 negative 21? Or 3
No.
321.
321. That's exactly what we get here, isn't it? Now, I am not claiming that this process made it easy to find the vertex. You with me? Because obviously it was easier to find the vertex the other way. Do I care? No. You still have to know how to take it from this form into this form. Okay, maybe.
Quick question. How come the vertex wouldn't be -3? Because as I'm looking at it here, I would guess it would be -321.
But you know better, because what kind of shift would this be?
Oh, never mind.
So remember, when it's in with the variable, it's the opposite of what it looks like. I know it's really, really easy to lose track of that. I understand. Oh, cool. Somebody told me they like this way better. That just makes my whole day. Even if you're lying to me, I'll take it. Okay. So let me see. How much time I have left? A little tiny bit. What was the last thing I wanted to do? Let me see. There was one more thing I wanted to do if I had enough time.
I have a question.
Go ahead. Yes.
What if that was set equal to 0? Would you do the same? Like the function.
That's a good question. All right. I know what you're asking. So let me do a problem like you're asking, and that'll be the last thing we do. Because I was thinking about doing this earlier. So has everybody got this business? Okay. All right, so what you're asking is, let me make sure I understand what you're asking. How would I use completing the square to solve a problem where it's equal to 0?
Correct.
Okay. So let's see, let's just start with, let's make it look like it's gonna be gross and then make it not gross. No, yeah, sure, why not? Let's make it not gross. I like it. Ooh, yeah. That's not bad. Come on. 2 steps, and then we can start completing the square. What's in the wrong place?
The X.
Yeah, so subtract that, dude. And then what do I want to get out of the way? Because can I factor this? No. So what do I want to get out the way?
The 7.
The 7?
Sort of like I did with that 3 earlier. I just pushed it away because I needed room. So let me get it out of here. I need some room. Make some room. And now we figure out the two steps. You can kind of do it in your head probably, right? Half of negative 10 is, half of negative 10 is negative 5. So I'm going to write that down here already. I already know what the answer is going to be. And then negative 5 squared is?
25.
The thing everybody forgets is I just changed the side. I better change the side the same amount, right? So then that factors like this. 25 minus 7 is 18. And then how do I solve this?
Oh, you square it now. You square both
Root,
sides.
plus minus, add the 5, simplify the rad 18. Yeah. So really, that's the most fundamental thing you do with completing the square is you solve a problem by putting it into something squared. So that's what completing the square does. It makes it in this form, and then you can solve it. And to be honest, sometimes this method is faster than quadratic would be, quadratic formula. Now, I'm not going to do it because I said that was the last problem we would do. But if I do all the steps to this problem, if I do all the steps to this problem, so divide by A, right, to make it 1, you can already see some stuff happening that looks familiar. Become an A. And then I can move the C over A over. I can take half of this, B over 2A. Does that sound at all familiar? Right? If I take half of this, isn't that B over 2A? You guys semi with me? Square it, add it to both sides, blah, blah, blah. I end up with the freaking quadratic form. You see, I still got kids out there. Shit, I should have closed the windows. I hate it when students bring their kids to class. I'm like, oh, okay. Dad, gummit. Scheisse? Does your kid know German? No? Scheisse. There you go. All right. Is that all right? That was a good question, Brian. I had thought about showing you that earlier. It's probably a good idea to show it to you. All right. Let me see what time is it.
And
Yeah,
you
I
can
think
use
it's.
that as, oh, my bad. You can use that to solve any equation, correct? By like
Any
factoring it.
quadratic, yeah, any quadratic, anything in the form that you can put in the form ax squared plus bx plus c equals 0.
All right,
You can use the process to solve it, of course. Because when does the quadratic formula work? Which is the shortcut of this. It works for any quadratic formula, any quadratic equation, right? So does completed square because it's just the long cut. So of course, sometimes you might end up with complex solutions, of course, right? But no big deal for us. We understand those suckers. Right? Okay. How's everybody else? You guys all right out there? Is that enough for today? You want more? Okay. God, you guys don't even say anything when I ask you that. I'll give you more if nobody wants to speak up.
Why
It
not?
feels like an. Say again. Sorry.
I said, why not?
Oh, some more. Okay. So I love that attitude. That kicks ass. All right. So a little preview of the next section because we basically covered everything you're going to see in here. Let me make sure real quick. Yeah. I like it. Somebody's calling me again. I love it. I'm teaching. Leave me the hell alone. So a little preview of the next section. When I say power function, what do you guys think? Anybody? If I say power function.
Function that's been raised to a power.
Yeah. So of course it'd be like x squared, x cubed, all that kind of stuff, right? Exponential functions are the ones where the x, the variable is up in the power, right? You guys with me?
Yeah.
So something like this, we're going to talk about later this semester. That's an exponential function. That's like in the horror movies when they say the creature's growing exponentially, right? That's the exponential function. So that's not where we're not quite there yet. So we talk about power functions that leads to polynomial functions, which is exactly what it sounds like, which leads to, let me see if that's in here. Not yet, okay. So the next section is what I call the real first step into pure pre-calculus. It's going to be analyzing, I have no idea how that makes you feel. We're going to be analyzing graphs of higher power polynomial equations and seeing, is there something I can see about the equation that tells me what the graph will look like, so I can graph it by hand better. Maybe. So we're going to start talking about something called n behavior. So what does x squared look like? It looks like somebody doesn't know. I don't know. What does x cubed look like? It looks like one of these guys that had a rough night, right? Fell out. That's the one my colleague calls a giraffe graph. Did I tell you this about that? Yeah, where you lost the front leg. I'm like, that's so evil. Corey, what the hell are you doing with these giraffes? Anyway, all right. So this is what I call n behavior. So this is the last thing I'll say. If I saw an equation like this is much more complicated than this already. Plus 7x minus 11. I already know that when x gets really big and when x gets really small, it's going to do that because of the highest power that I see. This shit is going to make it, oh shit. This business, I don't know where they are. I don't hear them anymore. This business here is going to make it wobble in the middle. Does anyone know how many turns it's allowed to have in the middle?
2.
At most 2. And we're going to talk about the idea behind everything I just said next time. I think there I'm going to officially end it for you and for me. So that's enough for today. All right, so we're going to get into the meat of pre-calculus, this next section. Yes, so if you want to hang out, ask questions, let me know. Yes?
Oh, I'm asking if that will be shown in section 5 once we get into it.
We're in it. We finished talking about section 5.1 just now.
I mean, like when we talked about it, because we didn't go over it. We did a lot of 4 in the beginning.
No, we did 5.1. That's the preview for 5.2.
Okay.
Yeah, so that'll be in 5.2. Cool. All right. Anybody else have any other questions? Are you guys all right? All right. If I don't see any questions, I'm going to head out.
I have a question about number 39 on 5.1.
All right. Let me. 39. Okay, I see. Oh, yeah. All right. It doesn't say which way to do it. So let me, good Lord. I love allergies. They're awesome. Let me share my screen. So this bad boy here, right? So it says, so you got to find the vertex, which we now know the shortcut for, right?
Yeah. Mm-hmm.
We got to find the axis of symmetry, which once you know the vertex, you know the axis of symmetry. It's x equals the x piece because it's got to run through the vertex. All right.
Yeah, for those problems, do you want us, is it okay to just write the coordinates of the vertex, or do you also want us to write out axis of symmetry and give the number?
Yeah, the axis of symmetry has to be the equation of a line. So never tell me the axis of symmetry is 7.
Okay.
The axis of symmetry is x equals 7. And of course, later we're going to talk about parabolas that open sideways. And then the axis of symmetry is going to be y equals something.
Yeah.
Yep. Yeah. So, and then when they say intercepts, they mean x and y intercepts. So x-intercepts can get a little gross sometimes, but oh well. So you don't have to complete the square on something like 39 because they don't tell you to, and we have other ways to answer what they want.
Okay, got it.
Okay. Anybody else? You guys all right out there? I'm gonna leave. Good night, everybody. I'll see you guys tomorrow.
Thank you.
Bye. Thank you.
Anytime. You're welcome. I got math all day.